Hey everybody, Mr. Regan here. And now that we've broken down what our experiment's all about, looking at the variables and such, we're going to now look at how we're going to be measuring and calculating velocity data. So we know when it comes to our experiment that within it, we'll need to measure and collect data that's going to answer the focus question. If the same strength force is exerted on two different objects, how might their change in velocity be different? Now, a while ago, we looked at velocity and how we figure out velocity. Today, we're going to look at how we calculate it using different equations so that we can answer this question. In order to thoroughly answer it, we need to obviously be able to calculate velocity. Just like we're going to need to be able to calculate the velocity of our pod when the normal thruster is fired with that unknown amount of asteroids during that lost signal time, we're going to need to do the same in our experiment. So the data that we're going to be collecting will require us to measure and calculate our dependent variable, or that change in velocity we'll see for our two different objects. This will help us answer that focus question and collect the data we need. So let's talk about it. In our experiment, we know that we're going to be using a launcher, the toilet spring launcher here, to exert the same strength force on the ping pong ball and golf ball so we can measure their velocities. You're going to use a stopwatch and a meter stick to help you measure the velocity of both the ping pong ball and the golf ball. So how do we measure and calculate velocity of our objects, or in this case, our dependent variable within our experiment? Well, let's talk about how to measure and then how to calculate velocity. So in our experiment, our two objects will be at rest, meaning their velocity is going to be zero. This means that when we exert a force on them, they'll have that change in velocity that we need to help answer that focus question. Now, you might remember this, you might not, but velocity is an object's speed in a particular direction. So to find velocity of our ping pong ball or to find the velocity of our golf ball, you're going to need to find their speed and the direction they're going. That's going to be tough, and that's where our measurements come in. So to find an object's speed, you're going to need to measure the distance it traveled. So that will be where we use our meter stick to measure its distance and the time it takes to travel that distance. So that's where the timer will come in, where you're going to be timing how far or how long it takes to go the length of a meter stick. Now, once you have these measurements, you're going to need to then calculate velocity. And that's where we have a set of equations that we use to help calculate velocity. So we measure the distance an object travels, we time how long it takes to travel that distance, and then we find the direction it travels, and we use this with some math equations to find an object's velocity. So we're going to look at a familiar example from a previous lesson that we have with our car here traveling from home to school. And in this example, they measured the distance it traveled, maybe using meter sticks or maybe using other tools. And they found it's 8 kilometers from home to school for the car. And it would take 15 minutes from it to get to home to school. And it's traveling to the right or east, depending on our frame of reference. So, how do we calculate the velocity of the car? Well, to calculate it, we know that velocity equals speed plus direction. Those two things. So we know we have the direction here, it's moving east, but how do we find the speed of a car? Well, that's where these two measurements come in. A car speed is distance divided by time. So distance divided by time. So how do I put all this together with my car data? Well, car velocity is distance divided by time plus direction. Don't get confused. We know velocity is speed plus direction. All I did was take this speed equation and put it into this part of my equation. So the car's velocity is distance divided by time plus direction. That's some basic substitution that we learned in math. So the car velocity would be 8 kilometers divided by 15 minutes plus the direction it's going, in this case, east. So all I did was plug in 8 for distance, 15 for time, and east for direction. So the car velocity, when I plug that into my calculator, would be 0.55 kilometers per minute east. And that's how I'd find the velocity. I would measure its distance using some sort of meter stick or something. I'd measure times using some sort of timer. And then I would use the equation speed plus direction, where I would substitute distance divided by time in for speed. So my final equation that I'm going to use is distance divided by time plus direction. So take a second. Do you understand how to use the materials to measure the two components for speeds? That would be distance and time. And you understand how to calculate the velocity of our object, similar to what we did with the car. Go ahead and fill out your survey. If you have any questions, reach out. Otherwise, good luck.